first off, Jaden, how come 4 remainder 1 isn't our answer to the problem?
Because there's one person who don't get a thank you card.
Okay, so that 1 remainder tells us this person's on the outside looking in. 28 guests are going to get a thank you card, but 1 person is not. How do we fix that problem so that 1 person isn't sad and doesn't get a thank you card? Malia.
You add 1 more packet, and he has to order 5 packets.
So we're just going to add 1 more whole packet. So instead of saying how many times can 4 go into 28, we're going to do what? It is. But how are we going to think about the problem, Bill? We don't have to use our remainder, so we need to go above what our divisor was. So before, our divisor was what? What was our divisor before? Olivia? What was our divisor for the problem? It was 7. So we did 7 divided by 29. But we didn't get enough. 7 times 4. So how are we going to change that? Olivia? We need to go above. So 4 is not going to work. Are we going to go down to 3? Jaden?
We're going to go up to 5.
Go up to 5.
And there's 6 left, right?
Go up to 5. Oh. 7 times 5 is what, Christina? We didn't get to our 5, but we will be soon. What's 7 times 5? Perfect. I don't even have to do that then. Now this is a funky problem. Because this is not how we do a normal division problem. Our remainder, or the product that we got here, is 6 more than what our dividend is. What does that 6 mean?
I like your hair.
No?
Yeah, I appreciate that.
Yeah, my mom has hair.
We have 6 more. That means we'll just have to give that person that one part, and we'll have 5 more left, so we can keep those 5.
We have 5 more left over?
Oh wait, no, because we give the other person 1,000. Because we had.
Oh, I see. I understand the problem.
No. Work your way through that thought. You're saying that 1 person is going to get his card. So now all 29 people have their cards. But we have, based on how many packages we got, we have 35 cards. So we have 35 cards. 29 are getting their thank you card. We're going to subtract them to figure out how many thank you cards are left over. So when the question asks you how many will you have left over, Jade, 6. Moo, you were thinking too deep, and you were saying, well, we need to add the 1 on top of that. The 29, though, is the total amount of people already. You know? Which is why the question said you must have 2 answers.
How about you just invite 28 people to this party?
Probably didn't think ahead. And you know, he probably doesn't consider the quantity of thank you card packages when he's making that decision. Okay, well, you know, when you have a party out or Olivia, you can kick somebody out or invite based on packages, your choice. The second problem that we did, there are 139 people, or 139 seats in a gymnasium. There are 9, yeah, we don't have one, so we're not privy to that sort of privilege. But it's like, yeah, a place where you actually go to have all, you know, assemblies and gyms. And in my school, our cafeteria was there too. 139 seats, 9 seats are in every row. But 1. 9 seats in every row but 1. David, what problem did you just set up? David set up 139 divided by 9. As I look across, I see everybody else set that up as well. Why did you set that up that way, David? So there's 139 seats in the auditorium total, right? Why did you put 9 as the divisor?
Because there are that many in each row,
But 1. Good. Don't read the whole problem and then try and work things out. Set the problem up as you go. The question asks, how many full rows of seats are there? So we set the problem up. Now we got to solve it. Jordan Wright. We talked about this briefly. but we haven't talked about this as a class yet. What we were doing was finding missing factor. So let's actually pause. Mark it down for a second and put your eyes up on me. I think I know why you have a feeling. Because I was talking to your mother about it. Waiting just for a few eyes. Perfect. Before, what we were doing is this. Okay, 9 times what is going to give us 139. But we had to do a lot of guessing. Maybe it's 12, okay, let's plug it in and try it. Maybe it's 13, let's plug it in and try it. And that was good because we need those skills of estimation. That's great. But there's an easier way to do this. Okay? When we see a big 3-digit number, or 4-digit number, so on and so on, we need to look at the first number that 9 can go into. Okay? 9 cannot go into 1. 9 cannot go into 1. What's the smallest number that 9 can go into? Adam? 9. The smallest number that any number can go into is itself. So it can't go into 1. Let's look at the next number though. 13. Can 9 go into 13? Is it small enough to fit into there in equal time? I hear yes and no's. Someone who's saying yes, tell me why, Olivia. Why yes? It can go in 13. 13 is bigger than 9. So 9 can go in 1 full time. Can it go in 2 times? Otto, what's 9 times 2? 18. So can it go into 13 2 full times? Otto? If 9 times 2 is 18, can 9 go into 13 2 full times? No, just 1. So, before, where we would look at the whole number and say, okay, it can go in this amount of times, we just broke it up. And we ignored the 9 for now and looked at the 13. Moo, how many times did we say it can go into 13? No, it can't go into 1. We say it can go into 13 how many times? Once. So we put the 1 up there. What did we learn we do when we put the quotient up there? We multiply it by what? Multiply that 1 by what? By the 9. And what do you get? 9 times 1 is 9. Here's the tricky part. We need to subtract it from the 13 to see how much is left over. So we multiply the 9 and the 1. And now we need to subtract it. Quickly do that on your whiteboard as I just did. And then eyes back on me. Think multiplication. Think how we strip away the zeros, do the whole numbers, and then put the zeros back. Okay? So if it's 30 times 5, do 5 times 3. 15. Add the 0 back on. I'm going to be done with them in 2 minutes, okay? And we're going to talk about that.
only on the first one.
Good. Now pause. I see almost all of us subtracted the 13 and the 9 and got 4, which I didn't even do. Wonderful. So let's have eyes back on me now. Kobe and Demia, we are coming to the carpet in 2 minutes. We will go over it then. Please take a seat. Olivia, why did you subtract the 13 and the 9? That's how we get our remainder. Normally, if the problem was just 9 and the 13, we'd be done. Our answer, 1, remainder 4. But we still have this 9 right here. It's still in the problem. It's still active. It needs to be used before we can be done. So Grace, what are we going to do with that 9?
Going to,
Well, we're going to add it on to something in a way, yeah. Christina? Or is that stretch? Okay, what do you think? We haven't taught this, so it's not the expectation that you know this. I'm just seeing what you have. Olivia? Drag it down. We're going to, you said add, right? And I thought that was a good word to use because in a way we are adding it down to our remainder. Normally that would be our remainder, the 4. But the problem's not done yet. We still have this 9 here. So we drag it down onto the 4. And it becomes a 49. Now the question is, how many times does our 9, our divisor, go into 49? How many times does our 9 go into 49? Are you simultaneously giving me a hand and the answer? Because you would, what is it?
The answer is 5.
Good. That's what I was saying. You were showing me the answer and giving me a hand at the same time. 9 times 5 equals what, Adam?
9 times 5 is 25.
Yeah, now I'm messing around the room, so I'm gonna do it over here. So a recap, really quickly, eyes on the board. A full recap of what we did. 9 times 1 went into 13. Christina, Moo, eyes on the board. Okay. 9 times 1 gave us 9. We subtracted. If that wasn't there, right, that would be our remainder, problem over. But the 9 is still there. It's still active, part of the problem. We brought it down. Now the question becomes 9 goes into 49 how many times? Adam told us 5. 9 times 5. Now we repeat the same thing we did here. It's 45. We subtract and get, David? David, please. Very well. If there was another number here, say an 8, our problem wouldn't be done. We'd have to bring the 8 down and blah, 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 blah. And we'll have, 5th grade to work on this. But at this point, there's no more numbers in our dividend. This is the last number. We can't solve anything else. So move. If we can't solve anything else, this becomes our
remainder.
15 remainder 4. Malia?
So you have 15 full rows and the other odd number of 6 and 1 on the 4.
Exactly. So we forget that we were just doing a word problem because we got so wrapped up. We have 15 full rows, like Malia just said, and that